With this project, we're looking to reimagine the way that we design and make civil structures. In this case, we're demonstrating a bridge.
This project is a collaboration with Dar Al-Handasa, and they are a large consultancy firm that focus on architecture, engineering and construction. We're working with them to reimagine the way that they design and manufacture large civil structures.
The idea with the project is to move from traditional construction methods towards workflows that perhaps are more familiar to the manufacturing industry. So we're leveraging a number of research topics for this project. So we're focusing on our advances in AI-based design workflows or generative design. We're also leaning on the growing maturity in 3D printing on a large scale or large format additive and how that works with our industrial robots. The bridge can essentially be broken down into two sections. There's the parts that we as engineers and architects have designed, and then there's the parts that the generative design algorithms have designed. We as engineers designed the ends of the bridge, the abutments. We also defined the span and the width of the bridge, and Dar gave us a deck shape that they were happy with and that they liked. And then generative design did the rest. So the branch-like structures on the bridge were all created by the generative design algorithms.
Chose various test artifacts that we would use to really hone in the parameters and develop the process parameters that we use with the extruder. Once we had those process parameters, we then went about programming it, and we needed to program it in such a way that we ensured the minimum layer time to ensure that we maintain heat within the part. So this involved us printing it in stages. So first we attacked the deck. The deck was the largest area, so we made sure that we spent time to really optimise the path that we use, incorporating the heated elements, so the heated lamp and the heated table. And then once we had that done, we then worked on the branches. So the branches are more intricate than the deck, but they also require shorter layer times because there's less area to print. So this was also done in a different way. So we really, again, really just focused our time on the most optimum path to ensure we got the best layer-to-layer bond.
The world is requiring ever more buildings and infrastructure and so on, all while meeting the challenges of climate change and social mobility and so on. So what we're doing here is we're trying to leverage some of the skills within the manufacturing industry to try and solve the problems that we see in the construction industry.